Okay, so this is 10.2. We're going to be making inferences from a random sample, standards, and an objective that you will be able to use a sample to get information about a population, again with an 80% accuracy given you practice problems. So we'll go over these 3 items and then we'll give you some questions to answer. Using the plots to make an inference. So for instance, if they're given the number of books that the students carry in a backpack, each one of them represents an answer that a student gave. First thing we're going to do is we're going to plot them, okay? So remember, we're going to use a little dot for each one of those data points. So I have 2 right here, so that's 2. And then I have 6. Then the next one is 1. And then I have 0. And that student either did all the work or it's not doing anything at all. And then we have 4. Then we have another one. 4. 2 and 2, so 2 2s. 1, 2. Okay, so I already have my dot plot, so now I can use that to answer questions. So for instance, I can ask, okay, what is the minimum number of books that students carry? That will be 0, I'm sorry. What about the maximum? 6. And then we can say, okay, what's the average, who was the most number of books that are carried? 2. Okay, so these are questions that you can answer by just looking at the dot plot. Okay, so let me ask you a question. Okay, so a question on this same sample, let's say the averages of the books that are carried in this sample. And then the other question that I'm going to ask you is, how many data points do we have? So how many kids were asked this question? And then to use box plots, I'm going to send you a video just to review this from 6th grade. But this is basically a box plot, or they also call it box and whiskers. So this little dot is your minimum, that's your maximum. This is your medium, so which is the middle number once you put them in order. And then after you get your medium, I'll do it right here so you can see. And then this is a IQR, the interquartile range, which is basically this from here to here. So you go Q3 minus Q1, and that should give you your interquartile range. So let me do it for you. First thing you need to do is have the numbers in order from least to greatest, and then I'll go from there. So what's my minimum? 0. What's my maximum? 6. And then I need to get my medium. So remember the middle number. So I have to count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means I can split them into 4 and 4. And the middle number is this one right here. Okay, so this is my median. So I'm gonna put my line right there because that's my median. And then after that, this is my lower quartile, and this is my upper quartile, right? So this is the lower numbers and the upper numbers. So from here, I'm gonna take the median to create my lower quartile, my Q1. Now again, the middle number, this is an even amount of digits, so there's nothing in the middle here. So I'm gonna have to take the 2 middle numbers, which is 1 and 1, and gonna average them. Averaging means I'm gonna add them together and divide by 2 because there's 2 data points. So I go 1 plus 1 is 2 divided by 2 is just 1. So that's gonna be my QR. So I can already do my first whisker there. Right here, same thing. I have nothing in the middle, so I can take those 2, and that's going to be 4 plus 4 is 8 divided by 2 is 4. Now imagine that this was a 5. So if this is a 5, I'm gonna change that there. If that's a 5, that's gonna be 9. So 9 divided by 2 is 4.5, so it will be right here. So I'm gonna do it right there so you can kind of see. I can create my other whisker, and then I can create my box now. So that's how your box will look like, okay? So again, let me ask you a question. Let's say this is number of siblings. So what is the minimum number of siblings that this sample has? What is the maximum number of siblings? What is your IQR? Your interquartile range. What is the median? Okay, and let me go over this a little bit. So we call it interquartile, so quartile, because they're divided into 4 parts. So this right here, you guys, represents 25 of the data. This right here represents 25, another 25, and another 25. Okay, so if I was to ask, what's in between what numbers is the majority of the kids that have siblings? I would say this is my 50%, right? Because 25 plus 25 is 50. So between 1 and 4.5, right? 4.5. We can all have 4.5 siblings, but so between 1 and 4.5 is where my majority of my data is located. Okay, let's go over this. Using proportions to make inferences. So first thing, you're gonna set up a proportion, and then you're gonna substitute and solve. So if I say that out of 10 I take a sample of 10 cookies, and out of those 10, one is broken. So then I'm going to see, if I have 25 cookies, what is the prediction of how many number of cookies are going to be broken in those 25. So I'm going to take the broken number of cookies in my sample. So that was 1 out of 10. So it's 1 out of 10. And I'm going to set it up equal to the actual number that now they're giving me. Okay. So I want to see 25. That's my population. That's the whole number of cookies. So it's going to go on the bottom. And I don't know what this is. So I'm going to figure that out. Okay. Different ways to do it. In this case, I prefer to use what I call the butterfly method. So I multiply what I have diagonally. So 25 times 1 is 25. And then I divide by 10. So 25 divided by 10. Remember, I don't have to do long division because I know when I divide by a multiple of 10, I count the number of zeros, and that's how many times I move this decimal to the left. Remember, there's a decimal always in a whole number, but we don't write it. So I have 25, and I move it once to the left. So it's going to be about 2.5 cookies are going to be broken. Okay, let me give you one to do for this one. Okay, so tell me how many broken cookies can we expect from a population of 54 if, using the sample, we got 2 out of 18 cookies broken. Okay? You're amazing, Berlin. You got this. We're almost there. Thank you. Bless you. Bye-bye.